With a good understanding of the network layer services, now we explore the options one by one. First, we start with virtual circuits. We'll explore what are virtual circuits and in a very cursory way because we have seen the details of virtual circuits elsewhere as well. We'll quickly round up the path establishment and path reversal. An issue of interest with regards to modeling and simulating to assess the performance is the stability issues, which are of direct concern both in virtual circuits as well as datagrams. Basically, virtual circuits provide source to destination paths which behave in a similar way like telephone circuits. The performance is almost guaranteed because the resources have been pre-allocated. The network actions such as call setup, data transfer, and call termination are also well known. Every packet that carries virtual circuit identifier belongs to the same flow, and subsequently, there is no need as such for source and destination IP addresses. Each intermediate device, such as an ATM switch, maintains the state of the flow and correspondingly provides treatment to it depending upon the service level agreement. The resources on the intermediate devices, such as the bandwidth, processing power, etc., are allocated to each virtual circuit. This figure actually identifies that there may be a variety of paths available, but virtual circuits tread the same path. Here you can see if we have 5 sources, each of these is generating packets. Each of the packets belonging to the same sender would traverse the same path. Of course, we are looking at a scenario in which the last device includes the flows from all of them merging together. You can think of it as being the router or a switch at the core of a network. Let's look at the stability issue. In virtual circuits, let's look at a scenario where we have 2 paths available. Both of them have the same capacity, link 1 and link 2. If the sender or the originator is interested in sending data to the destination, we would need to have some specific variables such as the bit rate represented in R, the channel capacity again represented in bits per second. Then what we are interested in is determining how flaky or fluctuating would the transmission be from the same sender to the same destination given that it has 2 paths. Well, it depends on how much time does it take to deliver the file. If the file is very large, maybe the routing updates occur more frequently and hence the paths could change. But if the file transfer is relatively smaller as compared to the duration of routing updates, then this fluctuation or oscillation shall not happen.